So, hello everyone. This is Wali Display. Uh, I'm a software architect, full stack actually. I have 10 years of experience and I'm based in Abu Dhabi. I just started my new challenge, which is learning machine learning and AI. Let's talk about the problem we have or the project we are working on. The project is a real estate appraisals and comms recommendation system. But the description of it is like the requested is to develop a system that creates property appraisals and recommends the most relevant comparable properties, termed comps, from a dataset of real estate properties. Yeah, so this is the problem. The system aims to, or the system features are to score each property based on its closest comps, which is this is the meaning of the appraisal or the details of the appraisal. Also, there should be an explanation of why we chose this comp over that comp. Why is this comp is close to the subject property that inside this appraisal. Yeah, and also the system should be able to learn from human feedback and like develop and to continuously improve. Yeah. So the machine learning approach I used for this project, I first started by applying the k-means clustering algorithm on a term frequency IDF vectorized text. So I started by like uh, applying the formula of the term frequency IDF on the text and vectorize it to create vectors for this. Or let's say I created a vectorized model. And after that, I applied the clustering, the k-means clustering algorithm on that vectorized model to group the properties details into clusters. So this is the first thing. After that, I used the KNN, the nearest neighbor prediction on the property numeric features using cluster labels as targets. And after that, I used cosine similarity, and it was applied within the predicted clusters, the clusters predicted from the nearest neighbor, to find the most comparable properties. In other words, the top n similar properties, and they are three, as requested. Okay, now I will go to the project. Yeah, so it's a Swagger for now. Only APIs. I don't know how does this work. Okay, anyway, I can do like this maybe. Okay, yeah, here is it. Uh, I want to make it full screen. I'm new to Loom, so yeah. No, it's not working. Okay, anyway, I think it will work like this. So I used Python Fast API, and this is a Swagger. So here I prepared an example. First API in the flow is the properties. So in this API we are posting properties details. I took them from the provided data set list of properties, and here we can add any amount of properties. And at the end of this here, we should like to put myself, no, not this one. Yalla, close. Okay, what's happening? Okay, so yeah, so here I set the property retrain to true, so the the model was retrained after posting these properties. And here is a summary of the the retraining and the properties adding process. This is the summary of it. Also, the clusters created, everything is here. Yeah. So this is the first step in the flow, adding properties and train the model. After that, we should go to post the appraisal, create a new appraisal. Here is a sample. The appraisal contains the subject. The appraisal contains the subject and its candidate properties. Here are a list also I got this from the dataset. And then we go and execute this API. The result is appraisal ID. A new appraisal was created and the status is completed because it's directly like the comps are directly selected for the appraisal on the creation. After that, we go to the third and the last API for now, which is the appraisal or the get appraisal. We provide this API with the appraisal ID, and we can check the result here. The status of the appraisal is completed. The subject, here is the subject that we posted on the creation, and here are the comps selected. So here we can see that we selected three comps. This is the default selection for the comps. Yeah, so this is it for now. Properties, appraisals, and get appraisal. Okay, the last thing is the remaining enhancements or the currently in progress enhancements. I'm working on building a user interface and adding the explainability layer and enabling the self-learning via user feedback, and also on migrating to a database backed storage system. So the database now used or the storage system used now is JSON, something simple, and I'm working on applying something like a real database. That's it, and thank you so much.